Hey James, welcome to all of you once again cordially to your own channel that is on JEE Physics Maniac. So today we are going to discuss a very interesting case, very interesting case, that is maximum energy storage between cylinders. So let us go through the question without wasting much time. That says we want to design a cylindrical vacuum capacitor with a given radius small a for the outer cylindrical shell that will be able to store greatest amount of electrical energy per unit length, subject to constraint that the electric field strain that the surface of the inner cylinder may not exceed E naught. Anyway, so what radius B should be chosen for the inner cylindrical conductor and how much energy can be stored per unit length? So this is a very good question and this can be tackled with two methods. I will definitely discuss one method and I will leave the other method to you. Okay. So here we are assuming, let us consider that B equal to C into A, that C is a constant out here. It's simply a constant, it's a multiplier factor. So you don't have to worry much about C. Now we know that electrostatic field energy density for electric field distribution, we know du dv is equal to half epsilon naught into E square, where E is the field at a distance R. Now, since E naught is the electric field and we know that for a cylinder, E is given to be, E is equal to lambda by 2 pi epsilon naught into R. This can be easily tracked with the help of Gauss theorem and you all know it's a standard result. So from there I can see that E is proportional to 1 by R. So I will use that particular data to find out electric field at point B, which is greater than R but less than A. So now in that case, E of function R will come E naught into CA by R, where CA is nothing but B, as we have already discussed earlier. So now U equal to half epsilon naught integration of B to A, CA to A, that's why I have kept this. E naught into CA by R whole square 2 pi R L dr. This is the volume here, cylindrical volume, right? Elemental volume. So after integrating, we get the result U equal to pi epsilon naught LA square E naught square C square ln into 1 by C. So now to find the max of U, what do you do? dc of this particular quantity is equal to 0, right? It's a standard result. So after derivation, we get C is equal to e to the power minus half. And if I substitute this result out here, we get U max is equal to pi epsilon naught LA square into E naught square by 2E. And it's a standard result. If you remember this result, I think it will be very helpful for you if question like this, which is definitely a perfect kind of question for JEE Advanced type of exam. Right, so it will be really helpful to you. Now what is the method to? I will leave up to you. Do let me know in the comment box and definitely if you try you will get the answer. I have full confidence on you. You are really champ, doing great. For people like us who are teachers, it is very easy because we only deal with one subject, and I think the students, you are the real champ because you have to deal with all three subjects simultaneously at the same level. Anyway, keep sharing, keep watching. Thank you.